That's right. So there's two libraries that I want to talk about, and let's see, it comes about from people not knowing about this. And let's see, I'll spend let's see, better part of a morning redoing these and realizing, oh, there is a place for these things. All right, so the first one is called More Iter Tools. If you're familiar with Iter Tools, then let's say it helps you to iterate through just about anything. You can make infinite counts. You can make, let's say, the ranges and what you can make let's see, zip up items, or what used to be in Iter Tools, iZip, but More Iter Tools is building on this, and we can do things like the collapse option. We can take an iterable that has lots of nesting inside it and just collapse it. It'll make a nice list out of it. Every once in a while you need that. Let's see, if you want to, I love chunked. So this allows you to take an iterable, whatever type or size it is, and it'll chunk it up into groups of 3, or 3 in this case. So you can keep on going. The interesting part is, what happens whenever it's not a nice divisor. It'll just chunk the last 2, so all by themselves. So anyway, if you're working with pagination, say, how many search results do you want on this page? So chunked will give you back the first 10 search results, followed by the next one, and just keep on going. MitSpy, or sorry, More Iter Tools Spy. This lets you not affect your iterable, but pull off the first item. And so we can keep that my iterable. It's going to change the form. So I have my first item off of my iterable here, A, B, C, D, E, F, G, but my iterable is still iterable. It does change the type, however, to an Iter Tools chain. So this is, if you want to pull off one item, you'll put a 1 here. If you want to pull off 2 items, you can get the first and the second item. So if you're familiar with rolling in pandas, you'll love sliding windows. So in More Iter Tools windowed, you can get the first 3 elements, followed by the, let's see, the element starting from the second item are 3 elements. Starting from the third item, get the next 3 elements. It's great if you want to do things like comparing years. Let's say you want to compare 2 years from the year, let's see, 1990s stock market, something like that. Let's say, get the differences between the 1990s stocks and the 1991 stocks, and just keep on going. You want to be able to get those differences and find out, did a particular stock do well? So, unique to each. This one's a quirky one. Let's see, because of all the rules that you have to maintain, and I think I've got a good, let's see, good example from this one. What is unique to each? This one has P's. The first word is Mississippi. The second word is Missouri. The first one has P's, and so it's going to be able to get all the P's. The second one has O, U, and R. Let's see, that is unique to that one. So it's going to pull all the O's, the U's, and the R's. Now, what it doesn't do is it's not a set. It's not going to count the number of S's that are in each. So in this case, there's 2 S's in Mississippi, or sorry, 4 S's in Mississippi, but it doesn't count these 2 S's. So it's kind of a quirky one, but if you find out a good place to use that one, it is, let's see, this one, the next one is sample. I don't remember my example for Mississippi, or unique to each, but MIT sample, this will pull off the items that, if you want 5 items just as a sample, so you want to do a test, for example, I'd like to get 5 items at random off of this iterable. So it's very useful. Exactly n. I love this one because it only pulls, or it only tells you if there are true values in this array of, let's say length 2, something like that. It's not any, it's not all, it's just exactly, this number of items in the list. So I often look for this. Let's see, is sorted, of course. If you want to not necessarily sort the thing, but you want to know whether or not it's sorted. There is another argument to this. So it can have a key. You can put in what, let's say, what your sort order is. But it'll just return true or false. And this one, let's see. If you're familiar with strip in strings, you want to take the values that aren't anything off of the front and aren't anything off the back. Maybe spaces are at the front, and non-printing characters off the front and back. That's what strip does. Well, this one is more itertools.strip, does the same thing. In this case, this pred, let's say variable, it defines what you want to consider as junk to take off. So in this case, I've got nones and I've got false and I've got an empty string. So let's chop that off of the front and back of these iterables, leaving an iterable of just 1, 2. Yes, it still has a none in the middle, but that's not really what we were focused on. We were working on what's on the outside of the iterables. So unique, just seen. In this case, it only pulls off the items that it's just seen. You can have, let's say, like, I can have more A's at the very end, and it will then pull off this A because it's not a set. It doesn't work like a set. So it just pulls off, hey, I've just seen a list of A's. I've just seen a B here, lowercase b, followed by some uppercase B's here. Just give me the first item that's different. Let's see, that you see next. So unique, just seen. All right, this one is an annoyance that I am constantly running into. Let's say, like, if a function that you're calling returns none, and then you stick it in a list, or let's say you assume it's a list or it's an iterable, and then you try to iterate over it, you're going to get this type error, and you're going to get a none type object as iterable, and then what you're going to do is put a try block around it so that you can catch that thing, just in case it happens to give you trouble again. And then you got to do the except. Except none, let's see, or type error. And then you have to come up with an exception or logic. No more. Stop. Always iterable. Take your variable that you get back from your, some function, and just put it inside always iterable. And I'm going to run this. Nothing. It just let's see, instead of giving a none type into X, let's see, returned a stop iteration. It said, that's it. That's all there is. So it assumed it's done. All of these tools are wonderful. They're small. And let's see, this one is probably the most powerful one of them all. Let's see, whenever you think of context managers, things like open, you don't think of, let's say, you think of it being in a block context. You're going to use this inside, you're going to use open with a with statement. You're going to have indentation and stuff underneath, and you're going to have lots and lots of lines. You know that whenever you write the context manager or whenever you're going to use this context manager, but no more. We can use this inside list comprehension. This will automatically close the context manager when it's finished. So you can use context managers inside list comprehensions. It can be small, it can be short, and I'm starting to use this all the time now. let's see, of course, I don't use open anymore. I use pathlib, but it's quite a wonderful tool for other context managers. So, and no. What else? The second library that I want to go over is called pandas profiling. This is a great tool for just finding out about unknown data. All right. So if you go to something like data.sandiego.gov, find out about your city. All right. Let's take a look at street repair projects. Hey, look, there's a download. I can download the CSV file, grab that, and let's see, inside here, I'm gonna run that cell and provide a report. I did pre-run this report, but I can download that, read the CSV file, and run this, something called profile report on this data frame. Move that away. What this is going to do is going to give us a series of correlations, a lot of data about missing variables. It does take a little bit. So let's see, it might take about a minute. Let's see, on this small data set. What it's doing is going to find out, we're going to find out about none values, how many missing values are there. So I use this whenever I don't know anything about a data set. I want to take a look at what are some of the problems? How am I going to clean this data set? This is the tool for you. So it just produces a nice, neat report. So here's the overview. I can get the number of variables, number of observations. So there's 3,285 rows in this particular thing. There's missing cells, 7.1%. Let's go down to the variables section. These are the individual columns. I don't really know what RD20 full stands for, but let's see, this is road repair work. So Gold Coast Drive seems to have the most repair work. So I can tell things about this particular data set without having to know much about what these columns stand for. I know that it's high cardinality, which means the values are unique-ish. Let's see, so I can take my distinct count. Let's say there's 14,000 out of 32,000 that are distinct. So it's 42.9% of the whole thing. Find out what the size is. There's other things like categorical. I can find out what the data type is, what it improved. Anyway, dig into this particular user interface. It's just nice. Let's see, I can find out some of the histograms, common values, frequencies. Let's see, the statistics. It gives different reports for different types of, let's see, types of rows. So anyway, check this out. It's a great exploratory tool, something that you can just add easily into an IPython notebook near you or Jupyter notebook. That's about it. Any questions?
I have a question, Jeremy.
Yeah.
So are you familiar with the bitwise operator in Python?
Sure. Bitwise.
What's the difference between the bitwise operator and the MIT iterable tool? It seems the same.
Okay. Let's see. You can use things like and, or, nots, those type of operators. So if in this case, let's say like this more iter tools, I wouldn't be able to use that and or not for this particular case. I wouldn't be able to use it for chunked to get 3 items at a time that I know of. I mean, let's see. MIT Spy, and there's no really way to pull off the first value of an iterable with an and or a not. So windowed, I'm trying to think of a situation where it might be comparable. So sample exactly n. Exactly n, this might be the case that you're talking about. So if I'm looking for two values, there's another one that you might want to use, which might be sum. That would get you close to this. So if I wanted to check if only two, let's see, sum might get you the same thing.
Sum, you could say sum equals 2. But then,
yeah, sum equals 2.
But I bet MIT is smarter. I bet they stop as soon as they reach 2 or 3. If they reach 3, they short circuit probably, knowing MIT.
They have to go through the whole thing. They have to iterate through the entire iterable, because let's see, they get to the end.
As soon as they have a certain true or false, they can short circuit on false. So as soon as they reach 3, then they can say false immediately without going and counting more of them. In your particular list of 3, yes, you're right. There'll be no difference, but it'd be faster on a long list with a lot of truths.
Let's see, strip just seen. Anyway, if you think of a situation that you would like to see a bitwise operator compared to one of these, I would like to hear it. So maybe we can talk afterwards.
Thank you, Jeremy.
Okay.
There's a couple of questions in the chat.
Oh, thank you.
One is, does this work with generators also? This comes from Leo.
There are some that work with generators. There is a
question was about getting the first item without influencing the actual iterator. So it seemed like it would be unlikely that you could get the first item out of a generator, because all sorts of things can happen during a generator that would end up in a very different result than just spying on the first item. That's my best guess.
Yeah, it could change it. However, if you make a copy before you or if you make a copy before you start, it's assuming that the internal state of the let's say each object is not dependent on more calculation. If that's the case, then yes, it can change. If it's not, then sure, you can spy on the first object. But maybe what you want is to see the data type. Let's see, consumer. This was something that you could use on generators as well. So in this case, you can start it off with a tally, and you can immediately send to that without having to do that next first. Let's see, next operation before the tsend can be used. So that's one instance where generators can be used. I'm stuck.
Thank you.
Let me see if I can.
These are all great, by the way.
Yeah. Yes, I can share this iPython notebook after. I'll put it in the meetup page and Slack channels after I get finished. I'll put it up on a gist in GitHub. Let's see.